This problem walkthrough video will demonstrate how to use the NORM.INV, RAND, MAX, COUNT, and COUNTIF functions along with what-if analysis in Microsoft Excel to execute simulation trials to analyze a tire warranty program. Here's the data for our problem. Greer Tire Company has produced a new tire with an estimated lifetime mileage of 36,500 miles. Management also believes that the standard deviation is 5,000 miles and that the tire mileage is normally distributed. To promote the new tire, Greer has offered to refund some money if the tire fails to reach 29,000 miles before the tire needs to be replaced. Specifically, for tires with a lifetime below 29,000 miles, Greer will refund a customer $1 per 100 miles short of 29,000. Construct a simulation model to answer the following questions. The data has been collected in a Microsoft Excel file, so download the spreadsheet and perform the required analysis to answer the following questions. A. For each tire sold, what is the average cost of the promotion? And B. What is the probability that Greer will refund more than $25 for a tire? Let's open up our downloaded Excel data file and complete the requirements. Here are the parameters for our problem as provided in the data. In cell C6, we have the estimated mean lifetime of 36,500 miles and the standard deviation of 5,000 miles in cell C7. In cell C10, we have the refund limit of 29,000, and in cell C11, we have the amount to be refunded of $1 for each 100 miles short of the 29,000 mile limit. Let's now set up our model. I'll enter a heading in cell A13. In cell B15 and B16, I'll enter mileage and refund and right justify them. Then in cell D15, I'll enter miles. I'll select cells C15 and C16 and shade them blue. Now for the mileage. What we want to do is use Excel functions NORM.INV and RAND, R-A-N-D, to generate a random mileage value based on the mean and standard deviation lifetime mileage. So click on cell C15 and type the equal sign, then start typing NORM.INV and select the function when you see it or press the Tab key. The first parameter is looking for a probability. Here is where we will use the RAND function to generate a random probability, so start typing RAND, R-A-N-D. The RAND function returns a number greater than or equal to 0 and less than 1, or simply a value between 0 and 1, which would represent a probability between 0 and 100%. The NORM.INV function relies on a decimal-based value, so a value between 0 and 1 is perfect. When you see the RAND function in the list, select it or press the Tab key. You'll see that an opening parenthesis has already appeared, and the function simply includes an opening and closing set of parentheses. So type a closing parenthesis, then type a comma. Now the NORM.INV function is looking for the mean, which will be the mean estimated lifetime mileage of 36,500 miles in cell C6. So click on cell C6, type a comma, and now for the standard deviation. Click on cell C7 to select the 5,000 mile standard deviation specified in the problem. Type a closing parenthesis and press Enter or Return, and you'll end up with a random number. My result is 30,779.05 miles, but yours will be different. Next, we want to calculate how much a refund would have to be provided to customers based on the random mileage, but is capped at the refund limit. To do this, we want to use the MAX, M-A-X function. Click on cell C16, type an equal sign, and type MAX. The MAX function returns the largest value in a set of data values. Select the function or press the Tab key. For number 1, enter 0 to represent the lowest possible miles below the refund limit of 0. Type a comma, and now we want to calculate the difference between the refund limit and the randomly generated mileage in our simulation. Type an opening parenthesis, then click on cell C10 with the 29,000 mile refund limit, then type a minus sign, and select the randomly generated mileage in cell C15. Type a closing parenthesis, then type the divide sign and enter 100, since the refund is based on the refund amount per 100 miles. Type a closing parenthesis and press Enter or Return. Now you might have noticed that the mileage changed, and this is because every time a new calculation is performed in Excel, a new random probability is generated to produce a new random mileage. I'll format the refund to be presented in dollars by clicking on cell C16, and from the number group in the Home menu on the ribbon, click the drop-down arrow and select the currency, which automatically formats the cell to 2 decimal places. I'll also format the mileage to include a comma and present with no decimal places by selecting the comma button in the ribbon and then clicking the decrease decimal button a couple of times. The refund amount is $0 for me right now, and that's because the random mileage of 33,931 miles is above the 29,000 minimum lifetime. The tire performs better than expected, so no refunds will be paid. If you press F9 and keep pressing it, Excel will recalculate the mileage and the resulting refund by generating new probabilities. Eventually, a mileage value below 29,000 will be generated, which would prompt a refund, as shown here, where a random mileage of 27,188 miles is generated, and the refund to a customer would be $18.12, which is calculated as $1 times 29,000 miles less 27,188 miles divided by 100. Now we want to create a simulation using trials in Excel, but before we do that, let's prepare our sheet for the results of the trials as they relate to the questions we're being asked. Requirement A asks for the average cost of the promotion, so we'll enter promotion cost in cell B18. Requirement B asks for the probability of having to refund more than $25 for a tire, so I'll enter prob of promo greater than $25 in cell B19. I'll select those cells and right justify them. Next, I'll select cells C18 and C19 and shade them green. I'll also enter per tire in cell D18. Now let's create a new worksheet for our trials by clicking the plus sign at the bottom next to the Model tab, and let's rename it Trials by double-clicking on the Worksheet tab. In cell A1, I'll type the word Trial, and in cell B1, Refund with a $sign in parentheses. I'll make those boldface and zoom the worksheet into 160%. Now let's determine how many trials we want to perform. Let's create 1,000 simulation trials by typing 1 and 2 into cells A2 and A3, then select those cells and click and drag the little green square all the way down to row 1001 in the worksheet. Excel sees the pattern, and the next number after 2 should be 3, then 4, and so forth, all the way down to 1,000. Next, I'll go up to the top and click on cell B2 and type the equal sign. Then click on the Model tab and select cell C16 representing the refund amount and press Enter or Return. My result is 0 now because the current randomized mileage is above the $29,000 mile refund limit. This is why we're going to simulate 1,000 trials, so we generate some results where refunds would have to be paid. Now select all the cells from A2 through B1001. Be sure not to include the header row. Then select the Data menu from the menu bar, and then from the Forecast group in the ribbon, click on What If Analysis. This drops down a menu, and we want to select Data Table since our trials are set up in a table. The Data Table dialog should appear, and for Row Input cell, leave it blank. And for Column Input cell, click on cell A1, where we have the heading Trial. Click OK, and just like that, Excel has generated 1,000 trials for a simulation. Select cells B2 through B1001 and format to eliminate the decimal places by clicking the decreased decimal icon in the number group until the decimals are all gone. Now let's go back to our model worksheet and answer the questions we've been asked. For the promotion cost in cell C18, we want to calculate the average of all of our trial results. So click on cell C18, type the equal sign, then start typing average, and when you see the function in the list, select it or press the tab key. Then click the Trials tab, which takes us back to the Trials worksheet, and select the cell range B2 through B1001 and press Enter or Return. Now I have a promotion cost of $2 per tire, but your result will be slightly different because of the randomization. Let's change the format to currency and show 2 decimal places by clicking back on cell C18, and in the numbers group, click the drop-down and select currency. Now for requirement B, we want to determine the probability of paying out more than $25 for a tire. Click on cell C19, type the equal sign. Start typing COUNTIF to count the number of cells in our trials that exceed $25. When you see the function in the list, select it or press the tab key. The first parameter is the range, and we want to specify the refunds in our trials, so click on the Trials worksheet, and just like we did for the average, select the cell range B2 through B1001. Type a comma, then for the criteria parameter, type an opening quotation mark, then the greater than sign, then 25, followed by the closing quotation mark, then type a closing parenthesis. This is instructing Excel to count how many instances there are that exceed 25 in the simulated trials. Now type the divide sign and start typing count to count the total number of values in our trials. When you see the function, select it or type the tab key, and for the value 1 parameter, select the same cell range we just used, so B2 through B1001. Then type a closing parenthesis and press enter or return, and I get a value of 0.03. Again, yours will be different. Let's format that as a percentage by clicking on cell C19, and in the numbers group on the ribbon, click the percent sign, and then click the increase decimal button to show 1 decimal place. If you start pressing F9, the mileage keeps changing, and so will the simulated trials. If you hold down F9, you'll see the numbers keep changing, but the probability will consistently be between around 1.8 and 2.8%. Thus, my final result is an average promotion cost of approximately $1.50 per tire and an approximate 2.1% probability of having to pay a refund of more than $25 per tire. And that's it. We've completed all of the requirements for this problem.